Hi everybody, hope all of you are well. In my previous class, I discussed the lab preparation method of hydrochloric gas and discussion of different types of questions. Today, I will continue this chapter. Now today first we will discuss that simple experiment to show that Hcl gas is heavier than air. Okay. So here first we have to take one clean gas cylinder or gas jar made of glass containing air and air is taken inside the gas jar. Then we have to pour some, or we have to take some blue litmus solution in the bottom of the glass jar. Next, the glass jar is covered with glass disc, and inside the glass jar what we can take? We can take one burning candle also. Then just above it we have to invert another glass jar, okay, which is filled with dry Hcl gas. Now next what will happen? We have to remove the disc or glass disc that separates these two cylinders, and we have to wait for 2 minutes. Then what will happen? The blue litmus solution turns red, and from here we can say that Hcl gas is heavier than air, due to which it moves down the lower cylinder and turns the blue litmus red due to its acidic nature. Okay, and if we take some burning candle inside it, then when Hcl gas will enter in bottom, that is the bottom gas jar, then what will happen? That air will displace and the burning candle fire will extinguish. Okay, if I draw the structure, then you can easily understand. So first we are taking one cylinder, gas cylinder, containing some amount of blue litmus solution. And inside there is air, and we are putting one glass disc. Okay, so inside there is what? Air, and above it we invert another gas cylinder containing dry Hcl gas. Now next step what we do? We will take the glass disc outside, so there will be mixing of these two gas. Now what will happen? That Hcl gas, as Hcl gas is heavier, it will come down. Okay, so and air will go above. Hcl gas will come down, and this solution from blue to it will turn red litmus solution. First it was blue litmus solution. Okay, so what is the observation of this experiment? Our main target was to prove that Hcl gas is heavier than air. Here observation will be being heavier than air, that Hcl gas displaces the air, from the lower jar, and hence if we take any burning candle inside it, okay, then the fire will be extinguished, okay, and it will turn the blue litmus solution red. Now what is the inference? Inference here you have to write that HCl gas is heavier than air. That will be the inference of this experiment. Okay. So next we will discuss another experiment. That experiment is called fountain experiment to demonstrate high solubility of HCl gas in water. Okay. So here first we have to take a large dry round bottom flask is filled with the HCl gas and by the displacement of air, and its mouth is then closed with a rubber cord through which passes a tube drawn out into a jet and a dropper containing a little water. The flask is now inverted and the end of the tube is now immersed in water containing blue litmus solution. Okay, now if we draw the diagram, the experimental setup, then you can easily understand. So we have to take first one round bottom flask that is inverted, and here is some rubber cord and it have to clamp with a stand, and now here will be one long tube one that is called jet pipe that will be dipped inside a blue litmus solution. It is blue litmus solution. And here will be one dropper. Inside the dropper, we have taken some amount of water. And here in the round bottom flask, there is dry HCl gas. Hope you can understand the diagram. Next, what to do? Now that few drops of water are introduced into the flask by pinching the tip of these droppers. This is the tip of these droppers. So if we pinch here or push here, then what will happen? Some water molecules or water will enter inside this flask. Okay. Now we know that inside the flask there is what? Dry HCl gas, and HCl gas is highly soluble in water. Okay, so the small quantity of water dissolves so much of the HCl gas that the pressure inside the flask is greatly reduced. So this creates a partial vacuum in the flask, and the outside pressure being higher, that is the air pressure, that will push this water here. So it will push this water. Okay, then what will happen? This blue litmus solution will go upward, and finally there will be formation of fountain. And what will be the color of the fountain? That will be red fountain. Hope you can understand. That is why this experiment is also called fountain experiment, to prove that or to demonstrate that HCl gas is highly soluble in water. Okay. Now, what will be the observation of this experiment? blue litmus solution turns red when it enters into the round bottom flask. This blue litmus solution turns red, okay, when it enters into the round bottom flask. Why? Because this is the acidic, the solution form here, that is the HCl is there and water is there, that is only acidic. Okay, so it will turn the blue litmus solution red and we will observe one red fountain. Okay, now what is the inference of this experiment? Two inferences are there of this experiment. One is HCl gas is highly soluble in water, and another inference is that the HCl gas is acidic in nature. But our main target was to prove that HCl gas is highly soluble in nature, highly soluble in water. Okay, but if we take some dry toluene, then what will happen? The solution of HCl in dry toluene neither turns blue litmus red or nor conduct electricity. This indicates that the absence of H plus ions in toluene. Thus, HCl is a covalent compound in dry state. Okay, so it will not produce any H plus ions. It can produce H plus ions only when it is dissolved in water. Okay. So next we will discuss the method of preparation of hydrochloric acid by dissolving the gas in water. Actually, a solution of hydrochloric acid gas in water is called hydrochloric acid. It is obtained by dissolving hydrochloric acid gas in water. If the solution becomes saturated with HCl gas and no more of the gas is dissolved in it, then the product form is called concentrated hydrochloric acid, and it contains about 36% by mass of hydrogen chloride. Now we have already drawn the diagram, the how HCl gas is prepared. Now if the delivery tube, okay, delivery tube through which the hydrogen chloride gas is coming out is dipped directly into a beaker, okay, containing some amount of water. The water is sucked back into the hot flask in which the gas is prepared, and this is known as back suction. Okay, and it might lead to a serious accident. Okay, when the water will enter into the main reaction mixture flask, here we are already giving heat. Okay, definitely the glass will crack. Okay, and there sulfuric acid is there concentrated. Huge amount of heat will generate, acid will spurt out, so there may be one accident. Now my question is, what is the cause of this back suction? We know that HCl gas is highly soluble in water, and so it creates a partial vacuum inside the delivery tube, and inside pressure becomes very low, but in the outside air pressure it is higher, and the air exerts pressure on the water. So the water enters into the reaction mixture flask and causes back suction. Now, how to avoid this back suction? So a special funnel arrangement mechanism or technique, okay, we have to use for avoiding the back suction. So here one inverted funnel is used at the end of the delivery tube, so that the funnel is just above the surface of the water level, and there should be some air gap. So if we draw the diagram, then you can understand what will be the funnel arrangement mechanism. So this is delivery tube from which HCl gas is coming. So just below this delivery tube we have to place one funnel. Okay. Now here definitely there will be the water container, water containing in a beaker, and we have to place the funnel just above, okay, the surface of the water, and there should be some air gap. Here is some air gap. And here we are passing that dry HCl gas. So HCl gas will come out, okay, from this funnel, and as there is no contact with water in this funnel, so HCl gas will enter into the water and there will be formation of hydrochloric acid. Okay, now what is the advantage of this funnel arrangement? First advantage is it prevents back suction of water, and the second advantage is it provides a large surface area to or for absorption of HCl gas. If we use only the pipe here, that means this delivery tube will enter into the solution. Definitely there will be back suction. Okay, so it is not done. As well as the area is very small, but here the area is very large. So this area provides a large surface for better absorption of HCl. Okay, this is the another advantage. Now sometimes before this delivery tube and the reaction mixture, okay, we have to put one flask. That flask should be empty. So an empty flask is placed in between the HCl gas generator, that means HCl gas mixture, that means NaCl and concentrated sulfuric acid round bottom flask mixture and the funnel arrangement. Okay, so between funnel arrangement and HCl gas generator we have to keep one empty flask. That helps to collect the water in case of any type of back suction. Okay, so if we take one flask, that will help, okay, to collect the water if any by chance, okay, there is back suction of water. Next we will discuss the reaction of HCl gas. In your syllabus only one reaction is there now, that is the reaction with ammonia. You know that ammonia is a base, so ammonia gas will react with HCl forming dense white fume of ammonium chloride. Okay, so that is the reaction of HCl and ammonia gas. It is a combination reaction or addition type of reaction. Okay. Next, if we take any kind of metal, these metal that are placed above hydrogen in the metal activity series will form their corresponding chlorides. When we will heat these metals with HCl gas and they will liberate hydrogen gas, it is a simple displacement reaction. Suppose if we take magnesium and take the HCl gas, okay, this is gas, and apply heat, then there will be formation of the chloride salt, magnesium chloride, plus formation of hydrogen. If we take iron, definitely it will react with HCl gas forming ferrous chloride and hydrogen. If we take zinc, that will form zinc chloride and hydrogen. Next we will discuss the chemical properties of hydrochloric acid. Generally, first we will discuss the reaction of metal with dilute acid. Okay. So if we take any active metal that are placed above hydrogen, okay, so that will react with dilute HCl forming salt and hydrogen. So if we take that magnesium and HCl, so now we are taking the acid, that means HCl gas dissolved in water forming hydrochloric acid. So we are taking that zinc plus HCl, twice HCl dilute, that will form zinc chloride plus hydrogen gas. Okay. If we take magnesium in the same way, it will react with dilute HCl forming the hydrogen gas. And this reaction proves that HCl gas contains what? Or HCl contains hydrogen. Next, we will discuss the reaction with base. Generally, HCl is an acid, and if we take any kind of base, metal oxide we can take or metal hydroxide, that will react with this HCl, that is acid, okay, forming salt and water. This is one kind of neutralization reaction. So if you take Cu plus HCl, that will form CuCl2 plus H2. That is metal oxide, that is base plus acid forming salt and water. And if you take any base like NaOH and HCl forming NaCl plus H2. So these are the neutralization reaction. These are generally they are exothermic reaction. There will be formation of huge amount of heat. Next we will discuss the metal carbonate or metallic bicarbonate that will react with dilute HCl forming salt, water and carbon dioxide. So if we take sodium carbonate that will react with dilute HCl and forming NaCl plus carbon dioxide plus water. Okay. Now if we take some metal bicarbonate, we are taking that sodium bicarbonate. Sodium bicarbonate will react with dilute HCl forming NaCl plus carbon dioxide plus water. These reactions are in your syllabus. These are very important. Okay. Always write balanced equation. If you do not write balanced equation, your mark will be 0. Okay. So be careful. Always write balanced equation. Next, we will discuss that metal sulphide or metal bisulphide. These metal sulphides or bisulphide react with dilute HCl forming salt and water and sulfur dioxide gas. So if I take sodium sulphide, Na2SO3, that will react with dilute HCl forming NaCl plus sulfur dioxide plus H2. Okay, so NaCl plus sulfur dioxide plus H2. If we take the bisulphide, that is NaHSO3, sodium bisulphide, that will also react with HCl forming NaCl plus SO2 plus H2. Okay. Next, if we take metal sulphide, that will react with dilute HCl and forming salt and hydrogen sulfide. So if we take ferrous sulphide, that will react with HCl forming ferrous chloride plus there will be formation of H2S gas. H2S gas is hydrogen sulfide gas that turns the lead acetate paper black. Now in case of silver nitrate will also react with dilute HCl forming silver chloride, this cardioid PBT, and there will be formation of HNO3, nitric acid. Okay. And this silver chloride is soluble in ammonium hydroxide. Okay. Next we will discuss the reaction of dilute HCl with lead nitrate. If we take lead nitrate and if we add dilute HCl, dilute here you will write, all case you write dilute. So that will form lead chloride plus there will be formation of nitric acid. Now this lead chloride is a white PBT. This lead chloride is soluble in hot water but it is insoluble in cold water. Next we can take sodium thiosulfate that will react with HCl, will form sodium chloride, sulfur dioxide and colloidal sulfur plus water. So in sodium thiosulfate solution is a clear solution. If we add few drops of dilute HCl, whole solution will turn yellow colloidal solution of sulfur. Okay. Next we can take one very powerful oxidizing agent, that is MnO2, that will react with concentrated HCl. This reaction is not now in your syllabus but you have to understand. So if we apply heat, what will happen? There will be formation of manganese chloride plus there will be formation of chlorine gas plus there will be formation of H2. Okay. Now in this case there will be formation of a greenish yellow gas when you will apply heat manganese dioxide with concentrated HCl. Here we are using concentrated HCl. Okay. So this reaction proves that HCl contains chlorine. Okay. And MnO2 here whatever we are using, that is a powerful oxidizing agent. Other powerful oxidizing agent we can use, that is red lead, we can use KMnO4, potassium dichromate, etc. Okay. So these reactions are very much important, okay, for your exam purpose. Always now, as time is very short and there is no school now, okay, there is only online class, you please try to concentrate on the syllabus. According to syllabus, if you read everything, okay, then you can manage everything. That is, time management is a very important thing now. If you complete the syllabus, then you can read your book thoroughly, and that are not in your syllabus, that also you can read. Now I will discuss a little bit of that out of syllabus. That very important thing, that is called Aquaria. What is Aquaria? Aquaria is a solution that can dissolve gold, platinum, etc. Okay, which are generally insoluble in other acids like concentrated hydrochloric acid, concentrated nitric acid. So how Aquaria is prepared? We have to take the 3 parts of HCl, concentrated HCl, plus 1 parts of concentrated nitric acid. Then this mixture is called Aquaria. And what will be the reaction? Here you have to apply heat, okay, or just by mixing you can prepare. Okay, just mixing these two you can prepare. There will be formation of NaCl. NaCl is nitrosyl chloride, and there will be formation of nascent chlorine, twice Cl plus twice H2. Now this nascent chlorine will react with the gold or platinum. Okay, if you take gold, that will react with the CCl, forming AuCl3, and platinum will react with 4Cl. These are the water soluble salt of gold and platinum, will form PtCl4. Okay, so AuCl3 and PtCl4, these are the water soluble salt. So hence Aquaria dissolves noble metal, okay, example gold or platinum, which are generally insoluble in all other acids. Next, one very important thing, that how to identify HCl gas. We have already discussed. If HCl gas is present in a container, if we take one glass rod, okay, deep into ammonium hydroxide solution, okay, then what will happen? That ammonia gas will react with this HCl gas, forming dense white film of ammonium chloride. Okay, so this is the identification test for HCl gas. But if you have a hydrochloric acid, here also you can do the same test, because hydrochloric acid also there will be formation of HCl vapor. So if you take the 2 bottles containing one HCl hydrochloric acid, concentrated hydrochloric acid, another ammonium hydroxide, then ammonia, from ammonium bottle there will be formation of ammonia gas, and HCl bottle there will be formation of HCl gas. When they will mix, there will be formation of dense white film. Okay, dense white films. Next, if there is hydrochloric acid, the important test here you can tell that silver nitrate test. If you add some silver nitrate solution to hydrochloric acid solution, then there will be formation of cardi-white purity of silver chloride, and this silver chloride is soluble in ammonium hydroxide. So if you add ammonium hydroxide to this cardi-white purity of silver chloride, then it will become colorless or soluble. There will be formation of diamine silver salt, AgNH3 whole twice Cl plus twice H2. In this way, we have completed your study of compound. This is the first, it was HCl hydrochloric acid gas, and finally we want to discuss a little bit of use of this HCl gas or hydrochloric acids. In industry, generally this HCl is used as dyes, drugs and paints. Okay, in different cases we are using. Okay, silver chloride, whatever we are preparing from HCl, okay, that can be used for photographic films. In tanning industry, HCl also used. In soldering wars, okay, also acid is required. In pickling of metals to remove the oxide coating on the metal, generally HCl is used. And in preparation of Aquaria, we have also used concentrated HCl. And finally, we can write that in laboratory reagent we are using huge amount of HCl. Okay, so in this way we have completed the hydrogen chloride. Okay, so next there will be, I think, some live classes. Live classes I will discuss if you have any doubts, or I'll discuss some questions answers. So today up to this, thank you.